Amazing people. Today what we're going to do is we're going to look at the normal distribution. Now, the normal distribution is a special case of a continuous probability distribution. And it's most commonly known as a special one because it's what's often called a bell curve. Now, as you can see, we've got a bell being shown here on the left. On the right-hand side, then, we've got a normal distribution curve. Now, one of the key things with a normal distribution curve is the shape is symmetrical on both sides. And what I mean by that is if I was to draw a straight line down the middle there, this point here would represent where we can find the mean, the median, and the mode. But in addition to this, the area under the curve on both sides is going to be equal. Now, with these three things, the mean, median, mode, if one of these values happens to differ from the other ones, what this is going to do is this is going to skew the data. But in the case of a normal distribution, these three will be equal. Now, when we're looking at a normal distribution curve here, one of the key things is in the center, where we've got the highest point, this is also the median and the mode as well. And this is generally primarily referred to as the mode. Now, as we get distribute here and move across, we're going to find that we have these other points which come into play. Now, each of these points here is going to represent a part of our curve. And in the case here, it uses standard deviation to help split it up. In the case of the first point to the right, this is going to be the mean plus 1 standard deviation. Then when we go to the next one across, that's going to be the mean plus 2 standard deviations. And lastly, we have the mean plus 3 standard deviations. And likewise, on the other side here, because it's symmetrical, we're going to have the mean less 1 standard deviation, because we're going lesser now, followed by the mean less 2 standard deviations. And lastly, we have the mean, which is less 3 standard deviations. Now, as you can see, most of the data in this curve is based around the center. And as we go up further and further, we find that we have less of the data being involved here. Now, one other thing when we're considering the normal distribution here is this is a continuous probability function. When we consider probabilities, we're dealing with the area under the curve. Now, because of its symmetrical nature, one thing we do know is if we only have one side of the curve, so this section here, this is going to represent 50% of the data. Likewise, if we have the other side over here, this is going to represent the other 50% of the data. But if we have to take the curve as a whole, so all of the space under the curve, therefore, given it's a probability density function, we're going to find that the total area under the curve is going to be equal to 1, representing all the possible options of probability occurring.